So now I will discuss another type of modulation, digital modulation scheme, in which phase will be differ. Waveforms will differ in phase. Okay. So every phase shift keying signal waveform may be represented as Sm of t gt into cos 2 pi fct plus 2 pi m minus 1 divided by m. This can be written as a theta m. These are phase. So this theta m is a 2 pi divided by actually 2 pi. You have to divide m equal points in the circle. Okay, to get the phase, m distinct phase. Okay, so that can be mathematically written like this: 2 pi divided by capital M into small m minus 1, where small m vary from 1 to capital M. Okay, these are m possible phases of carrier that convey transmitted message. So this is baseband pulse. GT is a rectangular. Assume this is a rectangular pulse like this, 0 to Ts. Height will be 2 square root of 2 Es by Ts होना चाहिए. Okay. Okay. This is this type of waveform. So this corresponding transmitted signal waveform like this. Okay. So equation 10 or 12 can be, because we know that cos A plus B can be written as cos A into cos B minus sin A into sin B. With the help of this trigonometric identity, I will expand this function. So I will explain, and I can written like this: gt into AMC, that is cos 2 pi m by m. Okay, like this. So now we will find the signal space diagram for PSK signal. So for PSK for m greater than 2, it is a two-dimensional signal, not equality, because when m is 2, then it's this 2 array PSK, also known as a binary PSK, that is abbreviated as BPSK, and BPSK is one-dimensional modulation scheme. But m greater than 2, like m greater than equal to 4, this is a two-dimensional modulation scheme. So it can be written as 2 like this. You can g of t into AMC into cos 2 pi fct. Okay, I can write in place of EG, it will be ES. Okay, because if I integrate an EG, for EG I have to square 2 ES by TS in between 0 to TS dt. So this wave will be cancel out, it will give 2 ES. Okay, so there will be some mistake. Okay, but procedure will same. Okay, so EG will be this, then EG will be this. You substitute EG like this, so 2 ES, then so this can be if we substitute here, Eg is to Es, so it will be 1 by root Es g of t cos 2 pi fct. Okay, so this is 2 Es by Ts. Okay, AMC into cos 2 pi fct. So this can be written as square root Es into AMC, and then this will be 2 by Ts cos 2 pi fct. Okay, I will correct and upload, but this will be process. Suppose there is some mistake here, I will correct. Okay, so this is two basis function, f1 of t and f2 of t. Okay, so if you know the basis functions, so you can calculate their vector, two-dimensional vector representation, Sm, kept boldface Sm. Okay, like this, where this Sm1 is projection of Sm of t with the basis f1 of t, Sm of Sm subscript m2 will be projection of Sm of t on the basis f2 of t. Okay, so this way I will calculate this. Okay, so this is constellation points. So let us take one example. For m is equal to 2, signal space diagram for BPSK, PSK, that is known as BPSK, binary PSK is known as BPSK. So constellation point for m is 2 is given by this. Substitute in this formula, substitute m is equal to 2. So this can be written as like this. After simplification, it can be written like this. Okay, so if I will for small m is 1, so this will be cos 0, this will be sin 0, so I will get this one. Okay, if I will substitute in the equation number 16, m is equal to 2, so cos pi sin pi is 0, so I will get this one, and cos pi is minus 1. Okay, so if I will plot, so this is one dimensional signal, and this is a constellation diagram, space diagram for the BPSK. Similarly, for m is equal to 4, PSK is also known as quadrature PSK, quadrature phase shift key, because if m is 4 means you are each phase differ by pi by 2. This is quadrature phase. Each waveform differ in phase phase pi by 2. Okay, so substitute capital M is equal to 4 in the equation 15. So I will get this. After simplification, I will get this. So I will calculate all the 4 points. Okay, in one way, you have draw a circle of energy square radius of square root Es and choose point according to, because this 2 pi this radian, so you divide 2 pi by number of, here m is 4, so this 4 points I will get 0 according to this minus 1. Okay, so pi by 2, so this m is small m 1, so this point, if m is equal to 2, so pi by 2, this point, if m is equal to 3, so this will pi, so this point, if m is equal to 4, so I will get 3 pi by 2. Okay, so this way I can calculate draw the constellation diagram. Okay, if I want to gray coded, so I will assign 0 0 this one, so one bit differ 0 1, the S3 will be 1 1, and this will be 1 0. Each adjacent point, this is adjacent point, differ by 1 bits. इसके adjacent point this, so each 0 1 and 1 0 from differ by 1 bit from 1 1. Okay, this is a gray coded constellation. Exam they ask draw the gray coded QPSK constellation diagram. So this way you can assign the bit. Okay, now we'll discuss memory frequencies shift key. So here will waveform differ in the frequency. So memory M orthogonal FSK signal waveform may be represented like this: square root 2 ES by TS cos 2 pi FC into T plus 2 pi M delta F into T, where delta F should be 1 by 2 TS, denote the minimum separation between adjacent signal for orthogonality of M signal. This SM of each signal are orthogonal. So dimension of this signal will be capital M. Okay, and this this equivalent vector representation will be M dimensional vector. So S subscript 1 vector will be first element will be only square root 2 ES, and remaining M minus 1 are 0. S2 of T means second point of vector will be square root ES, and remaining M minus 1 will be 0, and so on. In case of S subscript capital M, capital Mth point of this vector will be square root ES, and remaining this M minus 1 points are 0. So this way we can write the vector representation of this memory FSK signals. You can calculate distance between any pair of signal, that will be square root ES for all K and M. So it is also for M is equal to 2, so it will 2 dimensions. M is equal to 3 is a 3-dimensional signal. M is equal to 4, so it is a 4-dimensional FSK. Okay, so thus a constellation diagram will be this. So this point is representing square root ES 0, this vector, and this is representing 0 square root ES या EB, because binary case में ES और EB बराबर होता है. Okay, and then this will be binary frequency shift signals are equivalent to this 2-dimensional vector like this. Okay, and this is constellation diagram. Now another type of modulation scheme in which amplitude and phase differ for each waveforms. This is called quadrature amplitude. Find applications in microwave application, high speed wireless communication, asymmetric subscriber, telephone, 4G and 5G. For high data rate we are using in current generation for 4G and 5G we are using QAMs modulation scheme. Okay, and this is a generic, means a generalized modulation scheme. It include square QAM, BPSK, orthogonal BFSK, quadrature PSK, and multi-PAM as a special case. Okay, it can be as a combination of two independent quadrature memory signals are considered to form RQM, rectangular signal constellations. So constellation diagram will look like this. If you want to calculate the energy of this average and a symbol energy of this constellation diagram, using this formula you can calculate. Okay, remaining things are written, you can read. Okay, thank you for watching this lectures. Most of the content of this lecture I have taken from this book. You can refer this book. Thank you for watching.